So the moving average method, this is another method of estimating trend values or trying to fit a trend line through the plotted graphs or through the plotted points of the time series value, your y value, and the time value, which is your x value. So unlike the least squares method, this is a non-mathematical method. It does not result in a formula, but it's much more simple compared to the method of least squares. So here, this method makes use of a moving average, okay, which is an average of any set of any subset or group. So what we're trying to do here is finding that moving average. Not exactly finding it out moving average, but suppose we're given a moving average and we have to work with that in order to get the trend values, and we will look at it. We look at those the way of calculating the trend values for different yearly moving averages. We will look at that, but the choice or the length of the moving period average is important. And so this is any average of any subset or groups of data, which means that suppose we have data for the year 2001, 2002, 2003, 2004, 2005. Okay, so if we use a moving average of 3 years, so we'll take the average of these 3, then the next 3 years, and the next 3 years, so on. Whereas if you're using a moving average of 5 years, so we'll take the average of these 5 years for the next 5 years, and so on. So, and the choice of the moving period is important because that will determine the trend values. So here, what we do next is, the choice is very important, which means for the same data, we can find a 3-year moving average, a 4-year moving average, a 7-year moving average. Okay, so but there's a difference, okay, because we can have an odd we have an odd period, an even period, and because for even period we need to center the data, and for odd period we don't have to do that. But usually if we start with an odd period, we usually stick with an odd period moving average. If we start with an even, we stick with an even period moving average. So the choice is important, okay, because first of all, the least squares method is concerned with finding a straight line trend, or when you plot the points in the graph, you want to get a straight line. Okay, so these are your actual points and you want to find the trend line, and you try to fit a trend line, a linear or straight trend line. But this moving average method is actually a non-linear method. It does not give us a straight line. At the most, it can give us a smooth curve. At the most, it can give us a smooth curve, which means something close to a straight line. And then again, that again will depend upon the length or period of moving average. So let us take a look at that example. So here, if you look in this diagram, we have the actual data and we're fitting a 5-year moving average to this data and also a 7-year moving average. So let me just show you the actual data. So when you actually plot the data on the graph, this is how the actual data looks like. Okay, I'm just trying to add color to this line over here. So this is your actual data. Okay, so actual data is represented by an orange line. Let me mark that here. Then your 5-yearly moving average. Let me use a different color. So let me use okay, maybe pink color. So your 5-year moving average is this dotted line here. Okay, so the pink color is your 5-year moving average, and now for your 7-year moving average, let me use a dark blue color. Okay, so a 7-year moving average by this blue color. So what we notice here is that in case of a 5-year moving average data, we get a more smooth line or a smooth curve. Your 7-yearly moving data is more wave-like. Okay, so this tells us that if you want to have a smooth trend, or if we try to find a smooth trend, we should use a 5-year moving average. So the choice is important because the period we choose as the period of moving average will determine the shape of the trend line. And if we look here, this was your actual data. It was something like this. And remember, it's a non-linear method, this moving average method. So our aim is to find a smooth curve or something that is close to a straight line, and that will give us a close estimate of the trend values. So if we use a 5-year moving average for this data, for the actual data, a 5-year moving average from this diagram looks like this. Whereas the 7-yearly moving data, or 7-year moving average, looks something like this. So by looking at this diagram, we can say that if you want to get a smooth curve or a smooth trend, we should choose a 5-year moving average for this data, or fit a 5-year moving average for this data. So, and this 5-year moving average, okay, it has a meaning, it has significance, okay, because if you remember, we're dealing with time series data, and time series has different components: the trend component, the seasonal, cyclical, and the random or irregular component. And since we're dealing with yearly data, we are not concerned with seasonal variation. So we have the trend component, cyclical component, and the random or irregular component, which usually is taken together with the cyclical variations. So if we're using this period of moving average, and like in this diagram over here, when this data is plotted on a graph and we try to fit it straight, when we try to plot a trend line, remember in this method you'll not get a straight line, okay, you'll get a smooth curve. So if we fit for example, this 5-yearly moving average to this data gives us almost a smooth curve, whereas the 7-yearly is wave-like. So we get a smooth curve in case of a 5-yearly moving average because, okay, it means that the time series data follows uniform cycles of length 5 years. So moving averages will smooth out differences or the disturbances in this case, because we're trying to eliminate the other components and find only the trend component. And in this method, this becomes possible when the period of moving average is equal to the period of variations, or in other words, it becomes equal to the length or period of a cycle. Okay, and the length of period of a cycle, it means that suppose we have data, okay, so we have data that, let's say data that looks like this. Okay, so what determines the length of a cycle? So these are called the peaks of a data, the peaks of data. Okay, now the distance from one peak to another peak, that constitutes, so the distance from this peak to another peak, the time period distance, maybe this is 2002, this is 2005, so we have a peak in 2002, we have a peak in 2005. The peak is nothing but where data reaches a high value, or to be more precise, a peak is nothing but it lies between the start of an expansion and the start of a decline, okay, somewhere in between here. So this goes up, remains here, then comes back down. So that point in between these two phases, that is called a peak. So if we notice that we have a peak in 2002, 2005, and the difference between 2002 and 2005 is 3 years. Let's say we have another peak in 2008. So the difference between this and this is another 3 years. So on average, we have a cycle of 3 years. Now, if let's say, okay, okay, let me go back to this example. Now the reason we get a smooth curve when we use a 5-year moving average is because the length of the cycle, the moving period average, is equal to the length of the cycle, which means we get something like this. Here we have, as I've said before, the distance between two peaks gives us the length or period of a cycle, or the length or period of variations. So if you look here, a peak occurs at the year 2002, 2007, and 2012. Now the distance between 2002 and 2007 is 5. The distance between 2007 and 2012 is 5. So on average, we have a cycle of 5 years. So, and also because we're using a 5-year moving average, the trend looks like a smooth curve. But instead of 5, if we use a 7-yearly moving average, we will not get a smooth line. So you see, the choice of the moving average is important. Okay, so it depends on us. Okay, like for same data, we can fit a 3-year moving average, a 7-year, a 5-year, a 9-year, so on and so forth, and until we get a smooth curve. And so the choice or the period of moving average is the same. And if we get a smooth curve, the idea is that we're using a period of moving average which is more or less the same as the period of a cycle, or the length of variations, or the period of variations. So this way, when we have a case where we get a smooth curve, it means we are able to eliminate or remove those disturbances from data. And this way we're able to fit a trend. Okay, so the choice is important, but generally what we find is that the longer the period or moving average, the closer we are to getting a smooth curve. So like for example, this data over here, this is the revenue data, and this is the actual data, which means for the month of January, if we plot, this is the actual curve. The dark blue, that is the actual data. And using, let's say we want to find the trend, okay, the general direction or the tendency where data is moving. So if we use a 3-year moving average, okay, the one in blue color, blue greenish color, gives us a trend line that looks like this. Okay, it looks something like this. But if you fit a 5-year moving average to this data, we get an even smoother curve, which looks something like this. So this tells us, again going back to this example, that the moving average period is more or less equal to the period of the business cycle, or the period of variations in the data set. Okay, and let us take another example for this kind of data. For the same data, if you plot the graph on the data, the gray line here is the actual data, and for the same data, we're fitting a 3-year moving average, we're fitting a 5-year moving average, a 7 and a 9-year moving average. So this shows that if we increase the length of period moving average, we are closer to getting a smoother trend, or a smoother trend line. Okay, not a straight line because it's a non-linear method, but something which is close to a straight line. Okay, so that's usually the case. The longer the period, the more smoother the curve. Okay, but then again, we should look at the data, the type of data we're dealing with. because if you look at this example, even if we're using a 7-year moving average, a 5-year moving average gives us a smoother curve. So it depends upon the type of data. But remember, if we're using, because unlike the least squares method, we're able to find the trend values for all the years. In using a moving average method, some years are left out. Okay, like for example, if we are using a 3-year moving average, the first 2 years and the last 2 years are left out. In other words, we cannot determine the trend values. It is only for the values in between these years that we're able to find the values. In case of a 5-year moving average, the first 3 years are left out, the last 3 years also are left out. So it means that the longer the period, okay, although we're getting a smoother curve if we use a greater period for the moving average, but what happens is we're leaving out more years. So we would be getting a smooth curve, but we would be leaving out more years while calculating the moving averages. Okay, so in the next videos, we will work out, using odd period moving average, even moving period average for estimating the trend values.